All right, I just copied a solution off of Leetcode, but right now I understand it. So while I understand it, I'm going to explain it so that in the future, whenever I inevitably forget, I can re-explain it to myself. So the only thing I added was just the print statement, so it's easier to decode. Otherwise, the solution was made by this guy on Leetcode. Thank you, Mohammed. You are a lifesaver. So the question is, given an integer array of nums of unique elements, return all possible subsets. Can't contain duplicates, not a problem with this, since they're all unique. Return the results in any order. So initially what I was thinking about doing was, going 1, 2, 3, and then moving a pointer, and then getting 1, and 2, 3, and moving a pointer, and getting 1, 2, and 3, and then moving a pointer, and getting 1, 2, 3, and like empty set. But that didn't capture like what about 1, 3? So I was real lost until I looked at the solution. Solution's genius. We're going to be looking at binary. And using the binary, we are going to find every position that we need to hit. So I'm going to use the first example that we have here, 1, 2, 3. And so let's go explain through the code. So first, we set I to 0 and I less than 1 bit shifted to the size of the array. And so the reason we want to do that is because of the amount of combinations. Since we're looking at binary, it's 2 to the n, and we can get 2 to the n by doing this, 1 bit shifted left. So since, in this case, we have three numbers, there are 8 combinations that we can get. So we'll be starting like this and looping through it. Well, it's less than, sorry, my bad. It's less than 8. So it'll be from 0 to 7. So we can loop through. This is 7. So we have, our binary 0, 0, 1, 2, 3, all the way up to 7. And then next, we're looking at J. We're just looping through 0 to 2 in this instance. Because that way we're just going through every single number in the array. Now for the interesting part that I was not have been able to figure out on my own here, which is, I'm gonna line this up real quick. We're comparing the binary, and so this has absolutely nothing to do with what's actually in the nums array. We're just using a benefit of looking at binary here to make sure that we get every combination. And so the way that we do that, looking at this example here, is on our first iteration, I is going to be 0 and j is going to be 0. And so we're going to compare the binary and of 0 and 1 bit shifted left by j times. So we start off with 0 and 1. And, that triggers, that's not greater than 0. So there's nothing of value here. We don't push anything back. And then we'll bit shift over again. We still get nothing, and then that is true of the last place as well. So the entire time, we put absolutely nothing into subset. So whenever we exit this for loop, and we get here, we are pushing back an empty set, which can be seen here. Then we go through again. I is equal to 1, and again, we have 1 left shifted j times. So 1 left shifted j times is this. Well, no, sorry. It'll start off 0, so we have 1. So 1 and 1 is in fact greater than 0. It's 1. So we're going to push back nums at index j, which index j is 0. So we're going to push back the very first index here, which you see happens here. Then, j increments, and so now j is equal to 1, so we bit shifted over 1. this gets you absolutely nothing, and this also gets you absolutely nothing. Both of these will be 0, so we don't push anything back. We're just putting in the 1. Now, I is going to increment again. We are up to 2, and j is back to 0. Here, you look at the and of this, you get nothing. J increments to 1, and you get something. So now you're going to push back the j of 1, and the j of 1 is, or nums of j, where j is 1, you get 2, which we see here. And then for 3, you get nothing, because 2 and 4 don't and to anything. Now, 1 is going to increment again, and we get 1, 1. And this is the super important part, because now whenever we go through and we check, this is how we get multiple things into our subset, so we can push back the bigger sections into the return vector. So 1 and 1, yep, that's 1, we're good, that's greater than 0, so we're going to push back j of 0, which is 1. You see this here, j of 0 is 1. And then we'll increment j, so it gets shifted 1 over, and now we're getting 3 and 2, which is just 2. 2 is greater than 0, so we're going to take the j of 1, or sorry, nums j 1, and that is 2, which we see here. So now our subset contains 1 and 2, and then whenever we bit shift j again, this is nothing, so we don't put anything. So our subset is 1, 2, and we're going to push that back into the return value here. And that's basically how we get all of our values. Let's jump all the way up to now we're at 7, just as the final example. And then this will show you, of course, we take all 3 values. We take j at 0, we take j at 1, and j at 2. And that's how we get our 1, 2, 3. If anyone else watches me ramble poorly explaining this, I hope this was helpful to you. And for future me, I also hope this is helpful to you, because you're supposed to know this. Yeah.